Dr. Rosemary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the subject Computer Networks. Subject code is CS8591. So in this I'm going to take the topic reliable transport. So it's a transport layer. So transport layer services for this multiplex and demultiplexing, connectionless transport, UDP, connection oriented transfer, TCP is a reliable transfer. That we will see the flow control, connection management, and what is connect. So transport layer services and the protocols. It provides logical communication between the application process running on different hosts implemented in the end system, but not in network routers. So the network transport versus network layer service. The network layer data transfer between end system, transport layer data transfer between end system. It relies on enhances network layer services. It's a constrained by service model of network layer. The discussion sending letter from west host to east host, the postal service mail carrier. The postal service carries mails from host to host, Uncle Sam and Uncle Bill. Refers to mail connection distribution communication. Network layer. Host also called the end system processes application messages. Host also end system. So process is called the cousins. Application processor letters in the envelope. Transport layer protocol, Uncle Sam and an Uncle Bill. Network layer protocol, postal services. So service is constrained by the possible services. Transport layer is a logical connection between processes in the same system. It moves messages. So logical communication, the actual protocol transfer. So the host one, the ISO reference model, physical layer, data link layer, network layer, transport layer, application layer. It forward the packets to router 1, router 3 and 4, logical end-to-end connection through host. You can pass through number of routers and the number of hosts. So the communication between the physical layer, that's on the pair, the host 1 and host communication takes place. So sending, receiving, convert messages into 4 protocol data unit. So the breakdown the application messages into smaller chunks, smaller pieces, transport layer header. So 4 protocol layer data unit. Network layer each 4 protocol data unit encapsulated in the 3 protocol data unit. Receives 4 protocol unit, receives transport header, receives a PSMS packet, so process to receive. So internet transport services reliable, in order, unicast delivery. It have congestion control, flow control, connection setup. So UDP is an unreliable or best effort delivery, unordered unicast or multicast delivery. Services not available for real time, bandwidth guarantees, reliable multicast. So the schematics it's clearly given. The logical end-to-end transport along with the some number of routers and a number of hosts. Extends IPC service from host to host delivery to process demultiplexing. So multiplexing, demultiplexing and delivering received segments to correct application layer processes. So segment is unit of data exchange between transport layer entities. So TPD is a transport layer, transport protocol data unit. So in this P1 to P2, P3, P2 to P4. So segment will be having the header and the message, the application layer data, segment layer data, and the receiver. So it will do this multiplex as well as demultiplex. So multiplex is gathering data from multiple application processes and enveloping data with header. So loader used for demultiplexing, multiplexing or demultiplexing based on the sender receiver port number, IP addresses, source destination port numbers in the each segment, well-known port numbers for specific application. So look into the diagram. TCP or UDP segment format will be application data, message, other header field, source port number and destination port number. Multiplexing and demultiplexing examples are given. A simple telnet application or web server. So host A, source port is X, destination port is 23. So as far as server B is concerned, source post is 23. So server has to get reply to the host. The destination host is X. However, server allow multiple clients connecting at the same time if it's used. So use a diagram protocol, no frills, spare phones, best rate of delivery. UDP segments may be lost or deliver out of order app. So no connectionless, no handshaking between the UDP. Then no connection is established between. So the name implies it's connectionless. There is no connection between the Sender and the receiver know each UDP segment handled independently of others. So the TCP and UDP, UDP is having 8 bytes, TCP is 20 bytes, no congestion control. UDP can blast away as fast as possible. So no segment error checking, there is no checksum. Length in bytes of the UDP segment including header. Often used for streaming multimedia application, loss tolerant, rate sensitive. Other UDP uses so DNS and SNMP, reliable transfer over UDP, and reliability at application layer, application specific recovery. UDP checksum, it detect errors or the flipped bits in transmitted segment. Center and the receiver, center treat segment contents as a sequence of 16-bit. Checksum adds one's complement of segment contents. So center puts a checksum value into UDP checksum field. Receiver computes checksum of received segment. Check if computed checksum equals checksum field value. No error detected. No error detected, but maybe errors. UDP checksum example: 3 packets of 16 bits each. Adding the 3, calling it R, send the 4 packets, the original 3 and 1's complement of R to the destination. The 1's complement is given at the destination. The sum of 4 packets should be all ones. If the packet is damaged, it will be denoted by 0. So why provide for error checking? No guarantee that it's provided in the all other links between source and the destination. So transfer protocols, the principles of reliable data transfer. So sending and receiving process. So the complexity of the reliable data protocol, unreliable and unreliable. So RDT send side and receiver side, unreliable scheme. And the RDT send call from the above, pass 0 to deliver the upper layer. Call by the RDT to transfer packet over unreliable channel to receiver. So it called when the packet arrives on RCV side of the channel. So RDT to deliver data to upper layer. So getting started. So action taken on the state transition or event or action. So using finite mission to specify sender and the receiver. Reliable transfer over the reliable protocol. So sender and the receiver send the data, packet and the data. Wait call from the above, wait call from the below, extract packet. After receiving that, it has to extract packet data and the deliver packet data. So FTP may flip packets in that. The question is how to recover from errors. Acknowledgements. Negative acknowledgement. Sender retransferred packet on the receipt of negative acknowledgement. So message dictation of negative acknowledgement will be having. Acknowledgement is known as negative acknowledgement. So they send data, checksum, wait for the acknowledgement, wait from the above, wait call from the below. So then so the UDP sent receiver FM, then it will give the receiver data. Wait call from the above. What happens if acknowledgement get interrupted? Does not know what happens at the receiver. He cannot retransmit. Retransmit might cause retransmission of correctly received packet. Handling duplicates. Sender adds a sequence number to each packet. Sender retransmit current packet if an acknowledgement or negative acknowledgement is called. Stop and wait protocol. Sender sends one packet and waits for the receiver response. So checksum sequence number acknowledgements. Retransmission will be help but not enough. How to deal with loss? Sender waits until certain data or acknowledgement loss, then retransmit. So approach the sender waits for a reasonable amount of time for an acknowledgement. Retransmit if no acknowledgement is received within this period. If packet or acknowledgement just delayed, retransmission would cause packet duplication, but use of sequence number is already handled. Sequence number of packet being acknowledged requires countdown timer. Sender and receiver. Operation loss. Right from the above. So after session, the performance of RDT3, 1 Gbps link, 15 minutes end-to-end display, 1 KB packet. The utilization of sender, time DC sending, T transmit will be 8K packet divided by 10 multiplied by 9 seconds, 8 microseconds. Utilization is fraction of time divided by sender DC sending. So 1 KB of packet every 30 seconds, 267 KB throughput over 1 Gbps link. Pipeline protocols go back and select repeat. Sender allows to transmit n acknowledgement packet. Unacknowledged packet uses a window size n is for flow control. Base and next sequence for the sender. Next sequence. So a sequence number space. So next sequence number. So sender and receiver. Sender. So the receiver has to wait for the random. Initially base is equal to next sequence number. So go back in cumulative acknowledgement, the redundant send and timeout event, retransmit packet n and all higher sequence packets in window. One timer is required. Receiver respond by acknowledgement only. The acknowledgement send correctly received packet with highest in order sequence. Discard out of packets. No receiver is perfect. Back end selective repeat. So receiver individually acknowledge or collectively received packets, buffer packets as needed. For eventually in order delivery to upper layer, sender only resends the packet with acknowledgement was not received. Sender window n consecutive sequence number. Again limits the sequence numbers of sent unacknowledged packet. Sender receiver windows. Sender data from above within the sender window, otherwise it's return to application process. Timeout, it's only a signal packet then retransmit. So acknowledgement n send base plus n minus 1 mark packet n as received. If n smallest unacknowledgement packet, advanced window to back to base to next unacknowledgement sequence. Receiver packet n in RCV receiver base plus n minus 1. Send acknowledge n. So out of order, place in buffer in order. Also deliver buffered in order packets. Advance window to next not yet received packet n. So acknowledge n. Otherwise, selective repeat in action. Corrections needed. 1 2 3 4 2 3 4 5. So then 4 5 6. Yes, it goes on. Selective repeat retransmission or move packet. So sequence number 0 1 2 3, window size is 3. Receiver says no difference between those two scenarios. Incorrectly passes duplicate data as a new one. So what relationship between sequence number and window size? The window size is equal to size of sequence number minus sequence so space minus 1. So setting the window size, it's not allowed. So window size is less than or equal to size of sequence number space by 2. So possible questions are: write down the various transport layer protocols, explain about TCP protocol, discuss in detail about user datagram protocol. Thanks for